Hi, I'm Lee Teschler with EE World and Design World. I'm here with Ken Johnson from Teledyne LaCroix, and behind us we have an 8-channel oscilloscope that's set up to really take a good look at three-phase power you might have in motor drives or inverters. Ken, tell us a little bit about the claim to fame of this display we see here.
Yeah, okay, no problem. So what we have is our 8-channel 12-bit oscilloscope. It works up to 1 gigahertz. In addition to the 8 analog channels, it also has an MSO option as well. And the nice thing about it is we have a built-in package that can measure three-phase power in this table right here. I can set up in a very complete way to make all sorts of different measurements. It does harmonics measurements on the input or the output of the drive. It can measure in a static situation like this. It can also interface to motor mechanical, like torque and different shaft speed sensors, and measure mechanical power. And in addition to doing a static analysis, I can set up where I can do a very high speed, and I can do a dynamic analysis over a very long record. So for instance, if I have a changing load condition, then what I can do is capture a very long acquisition. In this case, it's 2 seconds, and then calculate those power quantities. And so here I get the same table of results with all my power quantities, but I can also then get a zoom in gate mode. I can zoom in on this area right here, and as I change the location, my table instantly updates to tell me the power values for that location only. So it gives me an ability to measure static power quantities and dynamic power quantities that a power analyzer can't do.
How small of a signal can you resolve in a scope like this?
Well, it's 12 bits,
12
so
bits.
if it's voltage, it can go down to literally a millivolt resolution, and the accuracy is 0.5%, which is more than 3 times better than an 8-bit scope. And the ADC is a 12-bit ADC. It's comparable in accuracy to that of a power analyzer.
So how do you analyze in the frequency domain with something like this?
Yeah, so we do a harmonic analysis on drive signals. So we have an add-on for this where we can do either a fixed frequency or a varying frequency analysis. So I can choose to do that on the drive output, and I can display a waveform and a table of harmonic values. I can also filter the output. I can either filter on the fundamental, and all these quantities here will be just calculated based on the fundamental of these waveforms, or I can define a range. The range can be like 3 to 10 harmonics, or it can be fundamental plus n harmonics, and I can again get these results just for that specified range.
That sounds pretty useful, Ken. Appreciate that.
Very useful for R&D engineers.
Indeed. Thank you.
Yeah, you're very welcome. Thank you.